Well, I want to go into a little bit more detail about units and how they work, and just start working on the programming capabilities of Mathcad. So let's look at units first. So I've got a template here. Let's look at some of the built-in units. So for example, C is the speed of light. So if I type in C and then the equal sign, that gives me the speed of light, and in my uh, the USCS system. And now here's the speed of light in the SI system. So I can change that. So let's say I have another variable, C, and then this time I hit the shift semicolon. So now I'm assigning a new value to this variable C. And let's say it's 25 meters. And hit enter. Okay. So now when I type in C and equals, I get 25 meters. So it has replace the built-in constant, the speed of light, with this new variable that I've assigned the value of 25 meters to. So if I delete this, though, and go back and type in C equals, now I'm back to the speed of light. The same way is true with S, Control G, whatever that is, I forget, Boltzmann's constant or something, then that's what I get. But I can go back in and I can reassign this as 5 kPa. And now when I type in sigma, I get 5 kPa. All right, so constants that are built in will be used in a template, but once you change them, then that changes the value for it. Now that's just a local. It's local to this template. So if you open up a new spreadsheet, it doesn't remember that. It reverts back to the built-in constants. But that's something you want to take advantage of. And like I said, you could reassign the value of pi to something else. Probably shouldn't do that because that'll mess it up. I would use some other constant. The other thing I will point out is variables. So let's say that I need, like in concrete, you need f prime of c. So let me put that in. I got an f, and then I hit the prime, or the single asterisk, single apostrophe, and then I hit control underscore key, and that's my C, and let's say that's 4,000 psi. Okay, so that's how I got the little prime symbol there. I hit the F, and then the single quote key, and then the control G, and then the subscript C, and that's how I got that. So let's look at some new. If I needed to find a new unit, let's say I wanted to find a unit called fortnight. I'm going to hit the shift colon, and I'm going to say, okay, that's 14 days. DAY is a built-in Mathcad unit. Now notice that the day is in blue, but the fortnight's not. So if I want to say 2-day equals, and change that to fortnight, okay, well that works, but sometimes it doesn't work. So if it doesn't work, sometimes you need to catch up on your variables and say, okay, that's not a variable, that's a unit. So I'm going to change that. So now I can express a year, 1YR, which is a Mathcad constant or a unit. I'll hit the equal sign, backspace 1, and then type in fortnight. And that gives me, there's 26.09 fortnights in a year. So I've defined my new unit, and it'll stay in this particular spreadsheet. It doesn't, it's not a global in that it goes into the Mathcad system, and now Mathcad knows that a fortnight is 14 days everywhere, but it's only in this spreadsheet where you define it. So the other thing I want to look at, let's look at another one that's a little bit easier. Let's say we've got a guy in our office named Doug, and he's always kidding about measuring things in Doug. So let's create a unit called Doug. So let's say that a Doug is 2 meters. Okay, and so I want to take a 100-meter field, hit equals, but I want to do that in terms of Dougs. Now I get the message that says Mathcad doesn't know what to do with this. So let's go back up and click on my Doug and change that to a unit. And now Mathcad recognizes it that there are 50 dugs in 100 meters. Or let's just look at how many dugs are in 1 meter. That's a half a dug. So that works out pretty good. All right, so let me show you one other trick to graphing stuff in 3 dimensions. Let me create this function, x comma y, hit the shift colon key, and let's make this a cosine of x, tab over, plus sine of y. So now I've got a function. So I click below that function, and now if I hit Control 3, then it opens up a 3D plotting, and I can type in F where the cursor is blinking, and then select somewhere outside of my field, and there you go. I've got a 3-dimensional plot of that function. Now, the other cool thing is that I can click and rotate that, and then if I go to the plot menu, I can also make it look better. So let me change the color of the trace there. Let's make it something AMEC-y, and then I can actually, or I mean wood, make it woody, and then I can actually put a surface on that. Okay, so now you can see that I've got this graph in 3 dimensions. I can change the range of my variables. If I click on the X, and let's say I just want to plot it from 10 to 0, I'm hitting the backspace or delete key, type in 0, and then enter, and then it changes the domain over which it acts. I can do the same thing to the y-axis, hit the delete key, change it from 0 to 10, and you can see how it changes the way it works here. Let me go ahead and change this to 0 as well. Hit the delete key, and then 0, enter. And you can see how the graph changes, and I can manipulate it. I can change the trace thickness. I can change the color of the fill. All right. And then, so it's a very quick way to get a 3D plot for a function. You can change it and it automatically updates. So that's pretty nice. Unfortunately, there's not a lot of, so you can get a function, and if I want to, I can evaluate this function. So let me evaluate it at the point 2, 3. So that's x equals 2 and y equals 3. And hit the equal sign, and it gives me the value of that. It's a negative 6.9. And so I believe that would be in radians, would be the units. So let me check on that. Yep, that's radians. So in degrees, that would be a minus 39.9 degrees. Would be the value of that function plotted at x equals 2 and y equals 3. All right, so again, and I got there by hitting just Control 3. If I want to do a quick 2D plot, I can hit Control 2, and it brings up the place where I can put these variables in. All right. So let's look at a beginning to programming. Well, before I do that, let's go back to the units. Here's a situation. I actually use my snipping tool to cut these from the ACI 318 concrete design code. So you can see you can change the size of these by clicking and dragging until you get them the way that you will look like you want. You can move them left or right with your arrow keys, or you can move them with your mouse just by grabbing the handle and moving it. So here's one of the things that is really great about Mathcad, and that it's, like I said before, it's totally ruthless in making sure that you're using consistent units. But here's kind of a problem. So in the code, if you have an empirical relationship, the units can be kind of screwy sometimes. So here's a perfect example. In the ACI concrete code, it says, okay, the modulus of elasticity of concrete is a function of the compressive strength of the concrete. So let me put this in. So I've got F, and I hit the single apostrophe, and then Control _ C, and let's just say 4,000 psi. Let me change my units back to the US customer units. Okay, so now I've got 4,000 psi. Let's say that I want to determine what the modulus elasticity of concrete is. And I type in F prime control underscore C and hit equals. Wow, my units are kind of screwy. What am I going to do about that? Well, there's two ways of handling it. One is that this is kind of an empirical correlation. Let me delete that. So I'm going to need to monkey with the units so that I can get the right answer. So, and the answer is in pounds per square inch. So one way to do that is to hit the underscore key and divide that unit by PSI. So now it's making it dimensionless. And then I can either change the 57,000 to PSI units. And now I'm in the right set of units. The other alternative, oops, I'm just hitting the backspace key here. Now I've messed that up. Let me go back and recreate it. There we go. So F prime of C is I can put it over here. And then I still have to delete it out. But I've got to do something so that I take this weird unit, which is the square root of pounds per square inch, and get it into the units that the empirical formula requires. And so sometimes you just have to make that happen. Now that I've got it, though, Mathcad knows what it is, and I can change this to, say, KSI, kips per square inch. Or I could change this to other units, kilopascals. Okay? So, you know, once I get the formula set up right so that Mathcad can recognize what the units are and manipulate them, then it can convert those to any particular unit that I want. So, the next thing I want to do on the introduction to Mathcad here is I want to show you how to write a little program. So here's another concrete problem that you have. So there's this beta factor which figures out what the equivalent rectangular stress distribution is. Those of you that have concrete, you'll kind of remember this. So beta sub 1 is a function of the compressive strength of the concrete within these limitations. So from 2,500 to 4,000, beta 1's 80.85, and here's the other ranges. So let's write a little easy program to calculate what this beta 1 value is based on what I input as my F prime of C. So I'm going to type in B, then hit Control G, and then while I've got the Control key held down, I'll hit the underscore bar and type in 1, and then I'll type in the Shift colon. So now I've got to define my program. So I go up to the programming bar, and the way you start a programming is that you hit the parallel vertical lines there, and that inserts a new program structure. All right, so that's the way you start a program. So, and the other point is that there's some commands that you can't just type into a program. You have to actually select. So the first thing I'm going to do is I'm going to select this if value. And so this sets up the structure. So Mathcad recognizes that I'm writing an if statement into a program. So I'm going to put if F prime of C. All right. Now let's go up to my operators. And I'm going to use some of my comparison operators here, is less than or equal to, if F prime of C is less than or equal to 4,000 psi, And actually, the way I need to do it, I need to do it so that it's between the values of 2,500 and 4,000 psi. So let me do that. So 20, hit my space bar, 25. It's all goofed up now. Let me start over again. All right, space bar. If f prime of c is so let's put this table into a program. So I'm going to create a variable called beta, oops, lowercase b, control G, control underscore 1, shift semicolon, and now I need to create a programming structure. So I'm going to select this button, which inserts a new program structure. Now Mathcad knows that I'm actually building a program. So there are some keywords that you can't type in because Mathcad doesn't recognize them. So in programming, if you're using a keyword, you have to select it from the menu. So I'm going to type in, my first if statement is if 2,500 psi is less than or equal to f prime c, which would be less than or equal to, I'm in the wrong place, 4,000 psi, then I want Mathcad to do something. I want it to type in the value 0.85. I'll hit my space bar and then the enter key, and now I can put in a new statement. So I can't type in else if, but I select it. Else if 4,000 psi is less than f prime of c, which would be less than 8,000 psi, then it's not as simple as just giving it a value. It's got to calculate what the value is based on this formula. So let me type the formula in. 0.85 minus 0.05 times parentheses f prime c minus 4,000. And I've got to put my units in here. Otherwise, Mathcad won't understand it. It'll give me an error message. Divided by 1,000 psi. I'm using my right arrow key, then the space bar, and then I've got another else if. So now if f prime of c is greater than or equal to 8,000 psi, then I want it to input the value 0.65. All right. But I'm not finished. And the reason I'm not finished is because there are other values that I could enter that wouldn't fit into any of these categories. For example, if f prime of c is 2,000, then Mathcad doesn't know what to do with that because I haven't given it a situation where f prime of c is less than 2,000. So I've got to tell it what to do in case that there's an error. And the way I'm going to do it is I'm going to give it to return a string that says error. All right, so now let me give it a value of f prime of c, somewhere up here, f prime c, and let's say 4,000 psi. And then select anywhere in here and hit the equal sign. and I get the right value for beta sub 1. Let's play with this a little bit because you definitely want to go through a checking process to make sure that it gives you all the correct values, and you should probably do a hand count. Let's say this is 8,000. I should get 0.65, right? And I do, so that's good. And if I got, oh, say 4,500, then it would give me something less than 0.85 because it's in this particular tree, the second one, it's going to say, okay, it's between, it's greater than 4,000 but less than 8,000, so I've got to go through the equation. So it should be something less than 0.85, and it is. So now let me check and see what happens if this is less than, say, 2,000. What if it's less than 2,500? Ah, error. What if it's 2499? I should get an error, and I do. What if it's 2500 or 2500? I should give me 0.85. So it looks like my program is working, and that it correctly calculates the value of beta 1, given that f prime of c, the formula for calculating beta 1 depends on the value of f prime of c within certain ranges. So this is one of the best example of a simple program to enable you to progress through a calculation so that when you're faced with a decision, that Mathcad can help you make the right decision based upon a program which is acting just like a function to give you the correct value for the variable that you're looking for.